Welcome to AminAcademy.com. In theory of equations, let us discuss about nth root of unity. An nth root of unity is a complex number that when raised to the power of n equals to 1. In other words, it is a solution to the equation z power n equal to 1 where z is the complex number and n is the positive integer. Now let us discuss detailedly. Let the complex number z equal x plus iy, where x is real part and y is the imaginary part. We know that. Now we can express this as trigonometric solution as x plus iy. In trigonometric way, we can write cos of 2k pi over n plus I sine 2k pi over n, where n is an integer and k is also integer, where 0, 1, 2, 3, 4, 5 like this. General expression. Now where here x equal, comparing real part, is cos of 2k pi by n and sine, that is y equal sine of 2k by n. Now multiplying, adding square and multiply, square and add x squared plus y squared is equal, x is cos 2k pi by n, that is cos square 2k pi by n and plus y square, that is sine square 2k pi by n. Write clearly here. Now we know that cos square plus sine square equal to 1. Theta is same equal to 1. Now we have, hence it satisfies the equation of the circle. Therefore x square plus y square equal to 1 satisfy the equation of circle. Equation of circle with origin 0, 0 and radius is 1 unit. If a complete number is represented by omega, that is therefore we represent all complete numbers are in omega, we can say omega equal e power 2 k by n. E power omega equal e power 2k pi by n by d Moivre's, by Euler's formula it is. Then we can say omega power n by using Euler's identity, that is e power 2k pi by n whole power n is of course e power 2k pi, which is equal 1. Therefore omega is the nth root of, therefore we can say omega is nth root of unity. Now, if you are using the De Moivre's theorem to complex numbers, omega 1, omega 4 2, omega 4 3, like we can use it. Now, this is the graph for, and this here, look at this theta. If it is 1 theta, this is the first power. Theta equal to 2 pi by n, like it's repeating. Now, regarding this, we will use some example problem. This properties of the nth root of the unity. Look at here. The nth root of the unity lies on the circumference of the circle, having origin 0, 0. The three cube roots of unities are like, we can use it any number of nth roots. Now, we'll use some example problem to understand this concept. Example, find the cubic roots of unity. All roots you have to find. Now, first, that means 1 power 1 by 3 is what? Let z equal 1 power 1 by 3. From this, we can say z cube equal to 1. Then z cube minus 1 equal to 0. Now we know that identity a cube minus b cube equal a minus b into a square plus ab plus b square is identity. Therefore, z cube minus 1 can be written as the factors z minus 1 into z square plus z into 1 is z plus 1 equals 0, which gives first z equal to 1 and z minus 1 equal to first factor equals 0, which gives z equal to 1. This first solution. Then z square plus z plus 1 equal to 0. By solving this quadratic equation, z equal minus b, that is z plus or minus root b square minus 4ac. Four into 1 by 2a, 2 into 1, which is equal, sorry, we have to use the coefficient only, z equal to minus b plus or minus root b square minus 4ac by 2a, which is equal minus 1 plus or minus root 3 by 2. Therefore, roots of cubic roots of unity are 1, that is next one, minus 1 plus root 3 minus root 3, which you can say this one minus 1 plus or minus root 3i by 2. Therefore, first root is 1, second root is minus 1 plus root 3i over 2, and third is minus 1 minus root 3i by 2. These are omega, cubic root of unity. Now, we'll do next example. What is the fourth root of unity? Find fourth root of unity. There are 4 roots you have to find. Now, let z equal to 1 power 4. 1 power 1 by 4 because what the power of unity, which gives z power 4 equal to 1. Then we can say z power 4 is cos of 0 plus 2k pi by de Moivre's theorem by I sine 0 plus 2k pi which is equal e power I into 2k pi where k equal 0, 1, 2, 3. Now hence z equal by using de Moivre's theorem z equal cos of 0 plus 2k pi by 4 plus I sine of 0 plus 2k pi by 4. The k is an integer. But therefore, we are using k is 0, 1, 2, 3. First k equal 0, then z equal k equal 0, z equal to 1, cos 0 plus k 0 here, I sine 0, which is equal 1 because cos 0 is 1. Then k equal 1. K equal to 1, z equal, if you put k equal to 1 here, 2 pi by 4 is pi by 2. That is cos pi by 2 plus I sine pi by 2, which gives cos pi by 2 is I because cos pi by 2 is 0, sine pi by 2 is 1, so I. Then k equal to 2, then z equal, if you are using 2 here, 2 2s are 4, 4 by 4 is 1, so cos pi plus I sine pi. Cos pi plus I sine pi is minus 1. Then k equal 3. Then z equal, if you are using z equal to 3 here, that is 3 is 6, 2 3s are 6 pi by 4, that is 3 pi by 2. Cos of is I sine of 3 pi by 2, which gives minus I. Therefore, fourth roots of, you can use fourth roots of unity are 1 I, 1 and minus 1, I and minus I. 1 minus 1, I minus I. And you can use it here. And minus I. These are the fourth root of unity. So far we discussed about nth root of unity and some example problem, that is third root of unity and fourth root of unity example problem we had. Please subscribe our YouTube channel.